Quick question before we even start. If an app takes 1 second to handle 100 users, how long do you think it takes for 1 million? If you guessed a few seconds, stay with me, because the real answer is closer to 3 hours. Same code. And by the end of this video, there's one number that's going to feel genuinely impossible. Keep an eye out for it. You felt this before. You open an app, and it just sits there spinning. That little loading circle? Somewhere, a developer wrote code that doesn't scale. And today is about making sure that developer is never you. Here's the first thing that trips everyone up. We don't measure code in seconds. Run the exact same code on a gaming PC and on an old phone. You get completely different times. So seconds don't describe your code. They describe the machine it ran on. And you can't control which machine your user has. So instead, we count steps. Not seconds, steps. How many operations does your code actually do? And here's the real question, the one everything rests on. As the data grows, how fast does the number of steps grow? Let me make that concrete. Say you read every name in a list. 10 names, 10 steps. 100 names, 100 steps. The work grows in a straight line. We call that linear. Now a different task. Everyone in a room shakes hands with everyone else. 10 people, that's 45 handshakes. 100 people, almost 5,000. You added 10 times the people, but the work grew 100 times. That's not a straight line anymore. It bends upward, fast. Okay, your turn. Here's a tiny piece of code. One loop running through n items. And inside it, another loop, also running through n items. Pause the video right now and tell me, what's the time complexity? Think about it. Got an answer? It's n squared, because a loop inside a loop multiplies. If you got that, you're already ahead of most people. Drop your answer in the comments. I genuinely read them. Now let me show you the whole family of shapes, because once you see them, you can't unsee them. Constant time, flat. It never grows. That's the dream. Logarithmic, it barely rises. Every step throws away half the work. Linear, the straight line. N log n, that's good sorting, still totally fine. Quadratic, it bends upward. And exponential. Watch this one run straight off the top of the screen. The notation we use to write these shapes down is the famous big O. And here's the relief. We throw away the small stuff. 3n plus 5 is just n. We keep the shape and drop the noise. Here's the one tool to feel the difference. The doubling test. When the data doubles, what happens to the work? Constant, nothing. Linear, it doubles. Quadratic, it quadruples. Exponential, it squares. Now, the number I promised you. At just 1,000 items, a linear solution does 1,000 steps. A quadratic one does 1,000,000. And an exponential one does more steps than there are atoms in the observable universe. Same input. One finishes instantly. The other will never finish. Not slow, never. Let's do one more together. You need to find a single name in a sorted list of 1,000,000. Option A, check every name, one by one. Option B, jump to the middle and throw away half each time. Pause. Which one is faster, and what's its big O? The answer is B. It's logarithmic, about 20 steps, instead of 1,000,000. Comment A or B. Let's see who's paying attention. Now, if you're preparing for interviews, this next part is the one that actually matters. Interviewers aren't testing whether you memorized code. They're testing whether you can look at your own solution and say, out loud, how expensive it is, and then make it cheaper. Classic question, are there any duplicates in this list? Your first instinct, compare every pair. That works, but it's n squared. In the interview, say it out loud. This is order n squared, I can do better. That one sentence tells them you know what you're doing. Better, sort the list first, then just check neighbors. That's n log n. Best, go through once and keep a set of what you've seen. That's linear. Notice the trade. You spend a little memory to save a lot of time. That trade, memory for speed, is the most common move in all of interviewing. So let's bring it home. Time complexity is just this. Count steps, not seconds. Ask the doubling question. Learn the shapes, from constant down to exponential. And remember the two rules. Loops inside loops multiply, loops side by side add. That's it. That's the thing people pretend is complicated. If this finally made Big O click, not memorized, actually clicked, then do one thing for me. You know someone right now who's struggling with this exact topic. Send them this video. It might save them a week. And if it helped you, a like genuinely pushes it to more people who are scared of this stuff. In the next video, we make Big O official, the precise definition, and its two quieter cousins, omega and theta. They sound intimidating. They're really not. I'll see you there.